Hi linear algebra students. In this video, I'm going to show that Pn, which is the set of polynomials of one variable with degree at most n, so it could have degree lower than n, but not more than n, is a subspace of the vector space of polynomials of one variable, okay? And we're going to do this by verifying the three axioms for subspaces, right? Because, well, that's what we need to do. And before we start, let's just say that P and Q are polynomials of degree at most n, if we can write them like this. And that being said, let's change this right away. So instead of A here, I will use B's. So we have like B0, B1, and that's it, Bn. And number one, okay, let's start. So number one is asking us, is the zero polynomial polynomial in Pn? Okay, and the answer is obviously yes, because the zero polynomial is the only one that has 0 degree, right? Oh no, it's not the only one, never mind that, sorry. So but the zero polynomial is a constant, right? So like 0 of x is equal to 0 for every x, has degree 0. Okay, which means that yes, it has degree at most n. So yes, it has degree at most n. Okay, of course here n is a natural number, right? A positive integer, so we're good here. Now, axiom number 2, we want to, okay, so if P and Q are in Pn, okay, is P plus Q an element of Pn? And for that, we have to write down what is P plus Q. So I'm going to write it underneath because I'm scared of missing space. P plus Q of x with the P of Q that I wrote over here, okay? I can say it's going to be A0 plus B0 plus A1 plus B1x plus all the way up. So in other words, remember that's how addition of polynomials is defined. You add up the coefficients. And as you can see, this has degree n. So has degree at most n. Don't forget, we say at most because nothing guarantees that this is non-zero. This actually could be 0. But we know for sure that we don't have terms after this one. So we're good. Now finally, okay, if P is in Pn and C is a real scalar, okay, we want to ask if is C times P in Pn. So actually, I'll just say here yes, okay. So again, the train of reasoning is simply to write what is Cp of x with the p of x that I wrote right here. So it's going to be Ca0 plus Ca1x all the way up plus C times, here we go, C times an, why did I blank here? Okay, x to the power of n. So again, as you can see, yes, it also has degree at most n. Like we're not getting suddenly a term of power x n plus 1. So it also has degree at most n. So again, the answer to this is yes. and we can conclude by saying, well, okay, well, all the three axioms for subspaces are verified, which means that Pn is a subspace of P. Let's even put the QED because this is so satisfying. There, I hope it helps. So see you either in class or in the next video.